Hello people, welcome back to this new video. I'm Srinidhi here. So today we gonna learn a very new topic called, and of course an important topic, that is types of registers in ARM. See, we knew that in the previous video taking out, so how many registers are there? There are total of 37 registers. Okay, so this is actually a very important question in your exam point of view. He might ask you to explain. We call this concept as a registers programmers model, or we call it as a software programmers model, or explain the types of registers. Okay, so types of registers, in which we will be explaining all the 37 registers. Okay, so I do not want to take not more than 15 to 20 minutes to explain this topic. So it's a small concept, but it's really an important concept. You need to know fairly, okay, very wisely how these concepts are gonna work. Okay, so see, ARM knew that. Okay, see how many registers are there. See, we have about total of 37 registers. Okay, before we knew that, what are all the different, how many operating modes we have? We have 7 operating modes. How many types of interrupts that we have? We have about 7 types of interrupts. See, observe here, out of 7 operating modes in an ARM, 2 operating modes do not require any interrupts to enter. What are those 2 modes? That is my user mode and system mode. So the rest 5 modes requires 7 types of interrupts to enter. So 7 types of interrupts based on different categories enters different types of modes. First we'll learn that and we'll move ahead with each registers. Okay, so out of see, here in user and system mode does not require any interrupt. So the rest 5, that is your FIQ, fast interrupt, IRQ, normal interrupt, SVR, that is supervisor mode, abort mode, and undefined mode. See, FIQ requires FIQ interrupt, IRQ requires, if IRQ interrupt occurs, it enters IRQ mode. Then if reset or clear is your software is used, it enters your supervisor mode. And prefetch abort and data abort operating modes enter your abort. And then your undefined type of interrupts enter your undefined mode. So total of 7 modes, out of which 5 modes requires interrupt, 2 mode doesn't require interrupts because it itself is default in the mode. Okay, so it doesn't require any interrupt to enter the mode. Okay, so this is how your interrupts gonna apply on your operating modes. That is the very first point thing that you must learn. Okay, second point, what is the total number of registers? We have about 37 registers. Out of 37 registers, I told you that R0 to R15, that is 16 registers are normal registers, and after 16 registers we call it as banked registers. So that bank registers we will study, okay, or the remaining registers will go one by one. Each and every register will take up and we'll try to study now. See, R0 to, see, we'll study in user mode first. Okay, so before that I want to take up a small example here. Okay, let's say we have a system where your instruction started its execution. So instruction is started at some point here. Okay, so if some interrupts occurs, so that your ISR is taken, okay, it execute itself, then it come back for the next instruction. This is my instruction 1, this is my instruction 2. Okay, observe properly. The next 2 minutes is very important you to understand. If you understand, you can rest, all other things will make you very simpler. You started your execution, you will go to ISR, okay, when an interrupt is occurred. So ISR gets executed, you will come back to the next instruction to be executed. See, when my normal instruction stops its execution and goes to ISR, what is the value that gonna change? Okay, who directs you to the ISR? Okay, we know that the PC contains, that is your program counter contains the address of next instruction. So if I want to execute my ISR, the value which was there in PC, I will store it at some location so that I'll execute ISR. After execution, when I am coming back to this instruction 2, I'll just load whatever the address back to the PC and I'll come back to next instruction. Okay, so instruction 1 is completed. When an interrupt occurs, your PC gonna load the next instruction at some memory so that it executes your ISR here. After completing your ISR, again the address which was there in the memory will be loaded back to PC so that PC comes and joins for the next interrupt execution. Okay. So this particular block or the memory, if we have observed the concepts of 8081 and 8086, okay, this block of memory we call this as a stack. Okay, so this contains a stack. Okay, what the stack contains? The PC's data. Okay, the next instruction's address will be loaded into the stack. Again, if we are making use of a stack operations, it's a memory. You people know that ARM does not support memory operations. The complete operations is based on what? Yes, my dear friends, you are right. It's always on registers only. Okay, I hope so you are getting the concepts very clear. Please make the concepts very clear such that you don't have any kinds of doubt during when you study. Okay, so PC, see, observe here again. PC is storing that particular address of next instruction to some block. So instead of using this block of stack, I will make use of a register called LR. Okay, what do you mean by LR? It is link register. Link register gives the link of the next instruction. It stores the value of stores the address of next instruction to be executed, which the PC gives. Okay, it stores the link of the next register. So we make use of LR here. Okay, so whenever your PC started, okay, your user started execution, whenever interrupt occurs, so each and every mode, when it jumps to each of these modes, each and every mode will be having its own link register. Let's say you please understand now. Let's come back. Please concentrate here for 2 minutes. You concentrate. I think you can get definitely, you can, I hope so you will understand the concept very clear. I have my IRQ mode here. I have my FIQ mode here. You forget about my FIQ mode here. Just concentrate on IRQ now. My user program is being executed and some interrupt occurs, that is your normal interrupt. Your program counter starts loading to your IRQ such that your PC value where the next instruction was stored in the LR of what? This particular IRQ. IRQ's LR contains the next instructions of the PC. So this IRQ, after completion of this IRQ, it again loads the LR value into the PC value which comes back to the user mode. Now look at the diagram. From the user mode, if I go to IRQ mode, your PC value of this, see I have represented, that's why in different color. I have written in pink color which is of new register. Okay, so PC value which is same as were in the user mode copies the contents into LR such that after execution of IRQ mode, your LR is copied back again to the PC and PC comes back to your user or system mode. This will apply to all other modes, so that whenever from the user mode to SVR or abort or undefined it goes, first it copies the contents of PC to LR, it completes the mode of operation, then the LR copies again will be switched back to PC, PC will be coming back to user mode. Okay, so now you might ask me a question, why do we require LR in my user or system mode. See, these are all the default registers which is already been there. Okay, we don't require. Okay, this concept is clear now. So totally we have we knew that R0 to R15 is my general purpose registers. Okay, apart from that we have different LR now. So why do we require LR? You came to know that. So 5 new LR concepts is done. Now come back. Please listen to me. Okay. See, any mode will be pointed by a stack, or we represent the mode with respect to flags. Okay, we require flags to represent the status of the register. Okay, which we call it as CPSR. So CPSR is the register, that is current point stack register or current point status register, in which we store the status of all the flags. Okay, so now when it enters into different modes, okay, your flag gonna change with respect to that particular mode. Let us say if your CPSR, if I enter from user mode to FIQ mode, or your supervisor mode, let us say, if it enters to this particular mode, during the execution of this supervisor mode, your flag gets affected. But while coming back again, when it goes back to your user mode, what do we expect here? Your flags, the changes of the flags, or your flags to be remain the same? Yes, you people, you're right. Our flag should not change at any point of time. So to that particular time, I'll make use of SPSR. Okay, so SPSR we use, it copies the contents of CPSR. When your CPSR is changed, the copied content will be copied back again to your CPSR, which will be get back to your user mode. So CPSR uses SPSR to retain its value when it goes to your new mode. When coming back, it copies the contents of SPSR and come back here again to your user or system mode. Okay. Now, so there are 5 SPSR for each and every mode. Of course, SPSR is not required for your user or system mode, because it doesn't goes to in itself. We don't require SPSR here. Okay. So 5 new SPSR is done. Okay. So apart from this, see, when we started executing any instruction within any mode, let us say we have abort mode here. Within abort mode, we have several instructions from R0 to R12. Okay, so it will be consisting of stack. Okay, we need, what is the responsibility of the stack? Stack contains the starting address of the location, so that that particular memory location will be pointing towards the top of the stack. Okay, if that particular top of the stack is being pointed, we need a stack pointer. That's why we require SP here. So for each and every mode of operations, we require new SP here. So taking new SP points to the current point of the first of the memory locations of the stack. So each and every mode requires one new SP. So total of 5 SPs are required. So 5 SPs, new SPs, 5 LR and 5 SPSR. So total of how many registers are done? 15 registers are done. Okay, so 15 registers. The next, apart from 15 registers, we have about 15 total of R0 to R15. We have the 16 registers which is done. Okay, apart from this, we have one CPSR for user mode, that is total of 17 registers that we are done with it. We knew what is SP, done. 5 new SPs and 5 new LR link registers and 5 new SPSR is done. Apart from this, we have the last 5 registers. Okay, it's very important, my dear friends. If you know this concept, you are done with the concept. Okay, that's it. We don't have anything with respect to this. Okay, of course we will take up the concept of CPSR registers. We'll take up different types of flag, which will be, I'll be making a new video of CPSR and how your flags gonna affect. Okay, each type of flag we'll discuss in detail when I start with the concept of CPSR. Okay, but right now for this instance, please make sure that we have 5 other new registers. Okay, let's say you have the concept of a normal interrupt and Fast interrupt. Okay, I just want to draw this. Okay, we'll take up a new diagram for this. Let's say, come back here again. I have started my execution. Here I have my instruction. From this instruction, I'll go to one ISR. I'll execute ISR. Come back to the instruction. This is my instruction 1. This is my instruction 2. Okay, when I start this ISR, this is a normal ISR. IRQ means interrupt request. IRQ is interrupt request. FIQ means fast interrupt request. Okay, so fast interrupt request and normal interrupt. See, in normal interrupt, if you say you store when this ISR being executed with respect to IRQ. Okay, so IRQ is being loaded means when it starts its execution, we require a block of memory or the stack in which it will be your interrupt request. ISR will be stored, and after each operations here it comes back to this particular instruction. This is with respect to your ISR, which happens to work with the stack, which is nothing but your memory. Okay, so now instead of we knew that ARM doesn't support memory operations. It concentrates and gives mind-blowing performance with respect to what, my dear friends, it's always registers. I hope so you know this concept, and I don't repeat it again and again so that you understand very much clearly. Okay, so now instead of this stack operations where it requires memory, and of course you know that if it is started executing in memory, what is the disadvantages of it? It kills the pipelining concept. There can be no pipelining because instruction fetch, decode and execute. I think I do not require to explain the concept again and again. If the first instruction is being fetched from the memory and first instruction is being decoded, and again if it wants to fetch the second instruction which is in the same memory, it stops the decoding of first instruction so that it started fetching the second instruction. So the pipelining concept is killed over there. I don't want my pipelining concept to be killed, so that's why I'll make use of FIQ, that is fast interrupt request, so that in fast interrupt request I'll be using 5 new set of registers, that is from R8 to R12, so that the responsibility of R8 to R12, R8, R9, R10, R11, R12. So total of how many registers, my dear friends? It's always 5 registers. So all these 5 registers are used for in FIQ mode, such that during the execution, whenever your processor switch itself from the user mode to FIQ mode, all these 5 registers are being invoked and FIQ operation is being done. Is the concept clear? Please try to understand. Don't by heart, my dear friends. It's very easy, and if you understand the concept, you can definitely write this diagram. There is nothing much in write. So this is what. So we are done with 5 new registers of FIQ also. We'll go with a quick revision of whatever the concept that we had studied this today. Okay, so ARM has how many registers? It is of 37 registers. Total of 37 registers are there. Out of 37 registers, R0 to R15, that is 16 registers plus your CPSR. Okay, current point status register is 1. So total of how many registers? 17 registers are done with respect to your user and system mode, in which there is no other register. See, there are register which the name remains same with respect to different modes, but the mode of operation of each register changes. Its principle changes, okay, with respect to different modes. Okay, now how many registers are done? R0 to R15, that is 16 registers plus CPSR with respect to your user or system mode. Apart from that, we have about 5 stack point register to represent at the top of the stack, which contains the address of that particular memory locations. Of course, we make use of LR, that is link register. When the program counter start executing or start moving to the next mode, the current status of the PC will be copied to LR. While coming back from the particular any other mode to the user mode or system mode, your LR copies the value to the PC again, so that your LR concept is done. Next, we have we have different status flags to represent each mode. CPSR, when CPSR start entering other mode, we want to retain the value of CPSR here, for which we make use of SPSR here. So SPSR, after completion execution of any mode, when coming back to user mode or system mode, it copies the contents of the SPSR to the CPSR register. At last, we have FIQ mode. Why do we require FIQ mode? We have the concept of two, normal interrupt and software interrupt. When in normal interrupt it uses stack, which is of memory operations, which is not being supported by ARM. That's why we go to the FIQ mode, in which 5 new registers are dedicated for that purpose only, to store the instructions are there in FIQ mode, that is R8 to R12. Okay, so total of 37 registers, 20 new registers are installed. So this is what the concept, guys. The concept is very simple. So I hope so you have understood the concept. So next video we'll meet again. All the very best. Bye bye.